Hi, morning everyone. So we're moving on to another interesting topic, prime and composite numbers. At the beginning of the school year, I've asked all of you to uh, memorize the prime numbers that are within 100. I hope you have done so. Today, we are moving on to some important theories behind um, theories that could actually help us to determine whether a number is divisible between 1 to 10. So please turn to page 58 in your student book. So we're going to go through some basic rules of divisibility. Divisibility means whether a number could be divided by um, another number. So we term it as divisibility. So in order for us to determine whether a number is divisible by 2, we need to know that the last digit is an even number. For example, 482, 2 is divisible, it's an even number. 0, okay, for this case, is an even number. So even numbers consist of 0, 2, 4, 6, and 8. What about numbers that are divisible by 3? Okay, it states that so long as the digit is the sum of the digits in the number is divisible by it's a multiple of 3. For example, 63 is to find out whether this 63 is divided by 3. So you just need to add the digits. 6 plus 3 is 9. So is 9 divisible by 3? Yes. So therefore 63 are divisible by 3. So likewise 642 and also 9252. When you add up the numbers, 6 plus 4 plus 2 is 12. 12 is divisible by 3. 9 plus 2 plus 5 plus 2, there's 18. 18 is also divisible by 3. So therefore these two numbers are divisible by 3. Moving on to 4. So how do I know whether a number is divisible by 4? So we just need to look at the last two digits. If that last two digits, okay, bear in mind you do not need to add them, just looking at the two numbers. The two numbers are 12. So 12 is divisible by 4. So that's the reason why 912 is divisible by 4. So numbers like 648, again you look at the last two digits, which is 48. 48 is divisible by 4. 32, you say 9132. 32 is also divisible by 4. Therefore, these two numbers are divisible by 4. Moving on to 5, I think that's quite standard. Most of us already know this. So long as the last digit is a 5 or a 0. So like 645, 7240, so long as the ending digits are 5 or 0, then the numbers are divisible by 5. 6. The last digit is an even number. Okay, first it must be an even number because 6 is an even number. And the sum of the digits is a multiple of 3. So just like 3, you have to add up all the numbers. So same thing for 6. You need to add up all the digits. So 18, 1 plus 8 equals to 9. And it is a multiple of 3. So therefore, it is divisible by 6. So look at this again, 6 plus 4 plus 8. So that's 18. 18 is divisible by 3. 8 plus 3 plus 4. So 8 plus 3, 11. 11 plus 4, 15. 15 is also divisible by 3. And these two numbers are divisible by 6. Unfortunately, there's no rule to find out the divisibility of 7. So you just have to use the whole the number and divide by 7 to see whether there's any remainder. If there's no remainder, means the number is divisible by 7. So numbers like 546, 9870, these are numbers that are divisible by 7. Next one, the last 3 digits are multiples of 8. So in other words, 160, it is a multiple of 8, or it can be divided by 8. Simply means, okay, so like 2392, let's look at the last 3 digits. If you divide by 8, is it divisible? 392 divided by 8 is 49. That's right, so it's divisible by 8. 512 divided by 8 is 64, which is also divisible. So by just looking at the 3 digits, since they are divisible by 8, so this whole number, these 2 numbers here are divisible by 8. 9. Interesting rule, the sum of digits is a multiple of 9. So you need to add up all the digits and then determine whether 3 plus 4 plus 2 is 9. 9 plus 4 plus 1 plus 4, that is 18. Also divisible by 9. So therefore, these numbers are divisible by 9. Last but not least, 10. I think all of us know this. To find out whether a number is divisible by 10, just need to look at the last digit. It must be 0. So long as 0, it is divisible by 0. Like 490, 210,430. So these numbers are divisible by 10. So use this rule to determine whether these numbers are prime or composite numbers. So by understanding all these rules that are given to you, you need to find out whether they are divisible, because once it's divisible by any of these numbers, then it will not be a prime number. Okay, like 54. Is it a prime or is it a composite? Because it's an even number, it must be a composite, isn't it? What about the next one? 80. Oh, 80 is an even number again, so it must be a composite number. Oh, 71. 71. If I add 7 and 1, no, we can't do anything. 7 plus 1 is 8. So it doesn't satisfy the rules for 3, 6, and 9. So therefore, it is not a composite, so it's a prime number. So there are many more questions available in the book. So I need you to spend your time wisely to determine those numbers, whether they are prime or composite numbers. Next, we are supposed to find out whether the numbers are divisible, okay, based on the rows, okay. Don't be confused. When I look at the tables, it was a little bit confusing. So what you need to do is you look at the whole row here. So you have 5 numbers, whether these 5 numbers are divisible by 2. So like 14, is it divisible? So if it's divisible, you're supposed to shade it. So you just need to shade it. Okay, since 14 is divisible, is 100 divisible by 2? Yes, it is. 248? Yes. 152? Yes. 2157? No, because it's an odd number, so therefore it is not divisible by 2. Moving on to 3. Is 18 divisible by 3? Yes. 396? Yes. 67? No. 225? Yes. 1233? Yes. How about next one? Divisible by 4. 28 is divisible by 4. 112 is divisible by 4. 1442. So look at the last 2 digits. Are they divisible by 4? No, isn't it? No. So what about 1347? I would not even consider it because it's an odd number here. How about this 2? So you look at the last 2 digits, 56. 56 is divisible by 4, so 3856 is divisible by 4. Moving on to 5. Yes, 50 is divisible. Sorry for the interruption. Now moving on to divisibility of 8. So 68. These 2 digits will not give you, they are not divisible by 8, so it's not 248. Yes, 248 is divisible by 8. What about this? Looking at the last 3 digits again, 480 is divisible by 8. Looking at the last 3 digits again, 344, it is divisible by 8. Okay, last 3 digit again, 560 is divisible by 8 too. 9. For 9, you need to add up all the digits, and whether the digits, the sum of the digits are divisible by 9. 8 plus 3 is 11. No, it's not divisible by 9. 1 plus 3 plus 5. Yes, it's divisible by 9. 3 plus 3, 6. 6 plus 4, 10. 10 plus 8, 18. Yes, it's divisible by 9. What about this? 3 plus 4, 7. 7 plus 4 is 11. 11 plus 8 is 19, so it's not. This one is 7 plus 5, 12. 12 plus 7 is 19, so it's not divisible. Moving on to 10. So 997 is not. 990, because last digit is a 0, is divisible by 10. 1040, yep, it is. 3395 is not. And 10,000 it is. So I hope you can complete page 58 in your student book. Feel free to contact me on direct message or send me a note on forum so that I could support you. Thank you.